Hello friends, my name is Abhisek Roy and I am currently studying from Maulana Abul Kalam Azad University of Technology, West Bengal, B.Tech in Information Technology Department. First of all, I would like to thank Shayantuni Madam to give me the opportunity to present this topic. Today I am going to talk about hashing. So this is our main agenda. First, we can see that why do you need hash function? What is hashing? And what is the disadvantages of hashing, and how to resolve these disadvantages. That means the collision resolution technique and that discussion. So let's start. So friends, now we can first discuss why do you need this hashing technique, because there is many type of searching technique is there. So let's take an example. So this is one data I am collected from the internet. One internet provider, there is in 2001 data, one internet provider, there is 125 lakhs of internet hosts is there, and this hosts are growing by 6 months is 20%. Now just imagine how much is growing is there. If we need to search this host, so there will be one search is there. There is many searching, but main less time we can search the element is one is technique is hashing. But why hashing? There is many type of searching technique. Binary search is there, linear searching there, but why we need this search technique? So let's take another example. So friends, let's take an example. Let's suppose there is one relational database. This is one database. Okay, this one database, and there is suppose there will be elements. Let's suppose there is 2 to the power 20 elements is, let's suppose. Okay friends, then we can, if we can search one elements, but one number, what one anything we can search. So friends, if we can use linear search, then it will be take how much comparison? It's take 2 to the power 20 times 20 elements is there. That means there will be 2 to the power 20 comparison is there. So that means there is big comparison. This is big comparison. That means there is much time to take this operation is happening. Now friends, now if I use binary tree, if we can use binary tree, then what will be happen that this same number of comparison is uh, here is binary tree, not binary search tree. It is a binary tree. Binary tree means there is one node, something is there. Okay guys, so there will also take 2 to the power 20 comparison. Now friends, if we can use binary search tree, then what will be happen? If we can use binary search tree, then there is two nodes and there is something 2 to the power 20 elements is 2 to the power 20. There is one is two node. Then what will be happen that in binary search, this happen is happen here is this take we know that the binary search tree is time complexity is order of log n. Then what will be the complexity? Then it is order of 2 to the power 20. Okay, this is less about 2 to the power 20. That means this search is good among linear search and binary tree. Now we can see that the time taken from linear search to binary search tree, there's less, and binary search tree and AVLT both take same time at most. Both AVL also take same time to log 2 to the power 20 here, and linear search it take 2 to the power 20. Let's reduce is there, but how to reduce that much? Now we can take B tree. So first remove these things, guys. First remove. Okay, now we can take B tree. B tree means there is B tree means one root node is there. Root node, we know that AVLT and binary search there is one root node, but here root node will be much more. Suppose here root node is 10, 20 and 30, and what is the less of, now here elements will be less than 10 is there, okay, and here is element of less than 20 and greater than 10 is there, and here also same as, and here also same as. So it take time of, here we can take the complexity is log of mn. That means its complexity is near similar to the 6. Now just imagine, first we take the comparison of 2 to the power 20 comparison is there. Now then the binary search is there, the comparison is to log of 2 to the power 20, something is less, and now we can see that in b tree or b plus tree the comparison is just 6. But there is another hashing technique that called hashing. So hashing takes order of 1. That means just one comparison and we can get the required element. So now we can understand that why hashing. So let's start the what is hashing and how to do these hashing techniques is there. So let's start. This slide is nothing but I can say previous slide whatever, this is same as same. Here we can see that binary search each take order of log n, and there is one good technique is there for searching, there is hashing techniques. It takes order of one time, and also it take many where it is application is everywhere almost. There is web search is there, there is one relational database what I have example previously whatever, that's also the application of this hashing. And there is compilers is one application, and then password authentication, there is one application of this hashing technique. This called is hash table. That means this is, let's suppose this is the key, and here is we can push the value, this is called the key value pair. Also this hashing is called also key value pairs. Okay, so next slide. But there is one disadvantage is there. What is that? Is that, let's see the picture, that these two elements is same going to the last index. So this is the main disadvantage is called the hash collision. Means two distinct elements are in same index. So how to resolve these disadvantages? Now we can see. To resolve these collisions, we can divide it into the two parts. First one is separate chaining or open hashing, and second is open addressing or closed hashing. Now we can divide it, the closed hashing, into the three part. One is linear probing, second one is quadratic probing, and third one is double hashing. Now we can discuss everything in the next slide. In the separate chaining method, all the elements were the keys. After using the hash function, we can slot the elements in the same table. It's similar to the linked list. So how to store the elements? First we can 8, 15, 22, 3 are distinct element. After using the hash function, we are in same index. So how to store in 3 distinct elements? We can store similar to the linked list. First we can store 8, then using the linked list we can 15, then after node 22. Thus we can store 3 distinct element into the same index. So this is the disadvantage of open addressing, as we discussed in the previous slide, that if you can delete the elements there, then we can rearrange or rehashing whole the hash table. Okay, this is the main disadvantage of this open addressing. Okay, so this is next one is open addressing. This is one collision resolving technique is in the open addressing to insert the key in the table. we simply hash the key using the hash function. If the space is available, then we can insert the key into the hash table. Otherwise not, we cannot insert the elements. So in the open addressing, there is three technique is there. One is linear probing. So now we can discuss the linear probing. Okay guys, so this is the one open addressing technique, name is linear probing, and this is the hash function after which we can use we can put the element into the hash table. This is the main hash function. Okay, this is h k comma I equal to h dash k plus I mod m. This is the hash function, and m is the whole size of the hash table. Okay, and h dash equal to k mod m, and this is the basic hash function. Okay, this is one disadvantage is in this method. Now we can discuss in the next slide. So this is the disadvantage of the linear probing, is that after using the hash function, we can see that one side there will be the one cluster is produced. So cluster means there is more collision in one side. Okay, so we can write that primary clustering is produced in the linear probing, and it takes order of n time. Now we can discuss the quadratic probing. In this quadratic probing, this is the hash function is there, and m is the size of the table, hash table. Okay, this is also much kind of similar to the linear probing, but here in the linear probing there is only I, not here is I square. So in the linear probing we see that there will be on primary cluster is happening, but here there will be on secondary cluster is happening. Okay, this is the main disadvantage of this quadratic probing. Now we can discuss about double hashing. So this is called a perfect hashing also. This is called also a perfect hashing. So here we can use two hash functions, that's h1 and h2. That's why in 99% case the cluster will not happen. So this is the main advantage of this double hashing. So this is the h1 means k mod m, and m means the table of the hash size of the table, and is also similar to h2k. So that's all my side. Thank you for listening my presentation. If there is any query, please contact me in through this email, and this is the further resources. If we can interest this hashing, you can use this link and go to the further research for this hashing techniques. So once again, thank you.